Hello, good day. I'm Jaime Pastrana. I'm here to share something about my expertise related to data architecture. For today's session, we will talk about data architecture and particularly in data architecture, there is data model. Okay, so what is data architecture and what is data model? Let's have first this image. So in data architecture, this is a design that requires uh, your pencil and your paper to identify what is data all about. But maybe there is another thing that you may ask. What is data architecture all about? And who works on data architecture? So to answer this question, let's have this. We may say that data architecture is that we orchestrate the data or we draw how the data works. And then for the data architecture role, we have here a data architect. So personally, my position is a data architect, and one of my tasks is data modeling. Okay, now let's proceed to our agenda for today's sessions. So for today's agenda, we will talk about all about data modeling and why data model is important. Then what are the building blocks or stages of data modeling? And then what are the requirements in data modeling? Example, the business rule, and what is latest about data model. Okay, then who involves in data modeling? For this introduction, as you can see, I highlighted here the designer, programmers, and end user. So we may say that IT is involved, ayan. Data architects are involved, but also the end user or the non-IT users or even you are involved in data modeling. If you use a certain procedures, if you use a certain applications, if you use a certain, or if you are part of a certain process, you are involved in data modeling. Okay, so as you can read here, a data model is all about a design for data, a data modeling, but we reduce complexities of the database design. So another word here is that data modeling is used for database design. And in data modeling, there is data abstraction. Okay, why data abstraction? We need to make sure that every layer of the end user, from the end user to designer to programmer, they can understand the data. Okay, let's proceed. So a little more definition about data model. It is a relatively simple representation of complex real-world of data structure. So oftenly it is graphical. Before or traditionally, we use paper and pen to draw your data model. But there are application now, or free or licensed application in which we draw the data model easily and as fast as possible. Okay. So when we say model, it's all about abstraction. Okay. We make sure, based on my definition a while ago, we make sure that everyone from the end user going to designer to the developer, they understand the data. And the word here is a real world object or event. Okay. So we make sure that the model is useful and easy to understand in the real world environment. Like example, if I am user of Facebook, I need to understand as an end user, not a programmer or designer, I need to understand why do I need to register? Why do I need to log in? Why do I need to post? So something like that. And then data modeling is an iterative and progressive process. So when we say iterative and progressive, there is stages, there is a cycle in which a data model or data architecture can improve. Okay, so let's move on. So what are the importance of data model? Again, we have abstraction, and from that abstraction, there is interaction. So interaction among designer, programmer, and end user. So we are involved in all aspect of data model or data architecture. End user have different views and needs for data. Yes, we have even you as student, you have your own view. Even your teachers has their own views, and we all have the needs for the data. Okay, what are your needs in Facebook? What are our views in Facebook? I need to post my status. I need to update my credentials or my informations. So I need to view all the posted status. Okay, like TikTok. Okay, but anyway, data model organize data for various user. Then data model is an abstraction again. So what you see is can a row require data, all about data and all. So for this session, we will talk about all about data and how we model the data. Okay, so what are the basic building blocks of a data model? So you just have to focus on the four major keywords here. These are keywords, not a process. Okay, number one, we have entities. Uh, on a layman's term, it's just anything about the data. Okay, that we need to collect and store. So try to think of it that this is a kind of table. If you use Microsoft Excel, we have table in Microsoft Excel, and then if you have registration, we have table for the student, table for attendees. So that is an entity. Okay, next is attribute. So attribute is a characteristic of an entity. When we say characteristic of an entity, it's just a detailed of your entity. A while ago, I said that in Microsoft Excel, there is a table. And then in a table, let's say we have a registration of student. So now, what is the attribute of student, or what are the characteristic or property of the student? So we have your student number, student name, student age, student address or addresses. So those are attributes or characteristic of an entity. And third one, we have relationship. Okay, can I relate it to the in Valentine's Valentine's Day, Happy Valentine's Day. But when we say relationship, it describes the association among entities or relationship of entities. Like example, uh, you have student table and then you have class table. So when we talk about association or when we talk about relationship between student and class, how can we describe the relationship? So here we have three examples of relationship that we can encounter during data modeling. Number one is one to many. We have also many to many, and we have one is to one relationship. Okay, so I don't want to relate it in Valentine's Day, but uh, these are common relationship in uh, in data modeling in which you can encounter this example during the architecture. Sometimes you can encounter many to many, or most of the time you can encounter many to many, and then there is one to many. Then there are minimal situation maybe that there is a one-to-one relationship. Okay, so when we talk about student and class, one student can can attend to one class. But if you will try to look at the other side of the relationship, one class can have many students. Am I right? Okay. Or we may also say that one student can attend multiple classes. Okay. So those are kind of relationship that we can encounter in data modeling. Now let's check what is constraints. So constraints is just a restriction that we place on data. Can we have that example? So let's talk about your student ID. So I think the restriction or constraint that we can identify your student ID is that every student ID is unique. Okay. There is no student ID that can be used by multiple students. So the restriction is we have unique student ID. Okay, so there you go. So let's proceed to our okay. One of the important requirement in data modeling before we start the actual design or the actual model, we have to understand the business rule. So business rule is just the description, policies, procedure, or principle. Let's just focus on this. Um, every transaction or every policies or every process has policies, procedures, and principle. Example, if you go to the bank, there is policies, procedure, and principle. If you go to uh, the store, there is policies, procedure, and principle. If you go to the libraries, there is policies, procedure, and principle. Then, if we will design a data model of, let's say, a library, we have to get all the data, all the information about their policies, about their procedure and principle, and then we will translate it into a data model. Okay, so I will not deep dive of this one, but let's have uh, get more information about business rule. It can be a company manager. You can get the source from the company manager, policymaker, department manager, written. So everything that or everyone who are involved in the process. You can set an interview to your librarian or to the people involved, even to the end user. You can talk to those people. Okay, then after we get the business rule, we can now translate it into a business into a data model components. Okay, so maybe everyone knows if you have your English subject, you know how what is nouns, you know what is verbs. So we can connect your English 101 to this data modeling components or to this topic. And then we can translate those requirements into a data model. So as what you can read this in this slide, nouns translated into entities and then verbs into a relationship. So let's have an example of noun. Let's say a student, a teacher, a class. Okay, those are nouns. What are verbs? Let's say student can enroll to a class. So the verb here is enroll. Okay, or what else? But we can explore more about that. But take note of this. Nouns can be an entities or can be your entities, and verbs can be your relationships. Okay, I will not deep dive on those examples. It's more technical, but in relational data model or in data model, it was developed way back 1970s. Okay, lolas pa. But the good thing about this, about relation model, actually this is commonly known as entity relationship diagram or ER diagram. But as you can see, from 1970s up to now, or in present time, there are evolutions entity relationship diagram or relational model. And we can see that in this example. Okay, so the relational data model or the development of entity relationship diagram from E.F. Scott during 1977, yeah, is being used in relational data management system or relational databases. And then it is for relational diagram that represent the relational table. So this one is a good example of a table which has link or relationship to the other table. So maybe we can explore this or just check all the entities. What are the entities here? We have agent and customer. So maybe this information is about a transaction that agent sells to customer, something like that, or who manage this customer. Okay, and then every agent, as you can see, has attributes. So what are the attributes? The agent code, agent name, agent first name, last initial, and agent phone number. On the other side, we have customer as entity, and the attributes are uh, we have customer code, name, phone, etc. And the relationship here, we have the link. So maybe we can created a name or word that describe the relationship. But please use the word or the verb. Okay, so this is the other side of the ER diagram without the data, only the entity and then the attributes. So what you have here is a relationship or association that tells an agent. One agent can have, this is infinite, means many, can have many customer. Or one customer can have one agent. So this is one-to-many relationship. And then next is we have relational model. So maybe we can skip this one. And again, there are evolutions of entity relationship diagram. You can see a chance notation or a chance method, and there is also a crossput notation. So let's skip this one. Okay, there you go. So this is on the left side is an example of chance notation in which you can see a different architecture. And then you can also see here on the right side the crossput notation in which this is almost the same thing but with different setup. Okay, so degree of abstraction we have conceptual, we have our external, conceptual, and internal. So actually, let's make it simple. Again, we have entities, relationship, process, and constraints. But let's have this one. Okay. So in data modeling, there is abstractions that the end user is involved, the designer is involved, and then the program is involved. So we make sure that the conceptual model can be understood by the end user, and then the logical, I call it logical, the internal model can be understood by the database management designer, and then the physical for the programmer. Okay, so this is an example of the conceptual. So there is entity, and then relationship. Okay, and then maybe we can also merge those association or those connection from student registration to class scheduling into one. Okay, this is for tiny college. And then this one is a good example of conceptual data model. Then this is a definition of conceptual. Again, just to make it simple, conceptual is when we want a data model that can be understood by the end user. And then for logical data model, this is can be seen or understood by the designer. So as you can see here, the difference is aside for this one, from the conceptual, it requires the attribute. and then the other definitions here, like a data type, is it a number, character, and so on. And lastly, for the physical data model, we have here the abstraction that can be understood by the programmer. So just to make it short, this is a deeper side of the data model, okay? Which this is part of the development. This is part of the programmer side. Before we end this session, I just want to have a quick summary about data architecture pertaining to data modeling. So when we talk about data architecture, it's just like doing architect of a certain building of your house. And then for each part of your house, there is a certain requirements or process that we need to follow. So same thing with data modeling. We have a process that we need to follow from conceptual that the end user needs to understand, going to logical, which the designer needs to understand, and then lastly, the physical model in which the programmer needs to understand the data. Okay, so we can use pen and paper to design your data model. But as what I have said earlier, in data modeling, there are also modern tool that we can use to design your schema or data model. So before we end, I just want to share this video. Okay, thank you.